So, hey guys, hope you are great. So in this live video, uh, I'm going to share notes with you on the mesh analysis. So in this case, as you can see from our diagram, we have assigned the currents I1, I2, and I3. So these are the currents that we have. So now, using the mesh analysis, uh, we have been asked to determine the values of I1, I2, and I3. So I'm sure we need to make some changes to this diagram. We need to redraw the diagram. So redrawing the diagram is the same as saying, so this is our diagram. So redrawing it is the same as saying we have. So let us draw it in the way that is very easy for us. So we have this, so let me go back again. So this resistor will be positioned like this. Here there is a voltage source. Again there is another resistor here. So positive on top, negative down. So this is 120 volts. So this is 120 volts. Then what is the value of these two resistors? 30. So we have 30. Then we have got 10 ohms. Even here we have got 30 ohms. So that's all. So now these are the currents. We have got this as our I2, then this is our I1, then this is our I3. So let us determine using the mesh analysis the values of I1, I2, and I3. So here we start. We name mesh by mesh. So we say a mesh, it is simply a path which is not enclosed in another. It is a loop which is not enclosed in another loop. So in this case, we have got this as our mesh 1, mesh 2, and mesh 3. So that is it. So we start with mesh. Let us start with mesh 2. Now we'll start with the one on. We'll start with this one. So with mesh 2, so I'll say mesh 2. So at mesh 2, I'm starting with mesh 2. So mind you, we say mesh analysis is the modified KVL. So we will be borrowing a leaf from the KVL. Then we modify it where there are voltages. We substitute with current and resistance. From the relationship of Ohm's law, we know that current, voltage, is equal to IR. So it is this relationship that we'll be using. Whenever there is a voltage, we'll be substituting with that. So here we start. So according to mesh 2, we have got that 8 ohm resistor, and the current that is going through it is I2 plus we have the 10 ohm resistor. So the 10 ohm resistor, we have two currents opposing each other. So there we need to subtract, but the current that determines the direction will be I2 in this case. It will be I2. So in this case, we need to subtract I2 minus I3. Then we have the magnitude of the current there, the resultant current, plus we also have another 10. So that 10 ohm resistor. There are two currents there, which is we have I2 minus I1. So all this is equal to 0. So we can reduce this to, we have 30 I2 plus we have got 10 I2 minus we have got negative 10 I3 plus we have got 10 I2 minus 10 I1 equals 0. So all that equals 0. So we can reduce this. So reducing this, we get we have 40 I2 not 40, but instead we get 50 I2. Collecting the like terms, we have 30 plus 10 plus 10, we have 50 I2 minus we have got 10 minus 10 I3 minus 10 I1 equals 0. So we can reduce that by dividing throughout by 10. 10 is the lowest common multiple. So if we divide throughout by 10, we get an equation that is equivalent to 5I2 minus I3 minus I1. This is equal to 0. So this qualifies to be equation 1. So we can move to the next. Equation. When we move to the next equation, to the next mesh. So in this case, let us go now to mesh 1. So which one is our mesh 1? So which one is our mesh 1? So here is our mesh 1. So from mesh 1, we do have there the 10 ohm resistor. We do have the 10 ohm resistor here. Here is our 10 ohm resistor. Then we have the 30 ohm resistor and the voltage source within this mesh. So in this case, we can go and write the equation. So we say we have 10, the two currents opposing there. We have I1 minus I2 plus we have got 120. So see, here is the voltage source. So we are moving in this direction. So we say we have got a 10 here and two currents opposing each other, which is I1 minus I2. So plus this voltage source. So here the voltage source has to be added. So we need to add the voltage source. So that's where we are coming from. So again, we have got a 120 there plus 30 I1 equals 0. So we have got 10 I1 minus 10 I2 plus 120 plus 30 I1 equals 0. So we can reduce this. So we have got this 10 plus 30 there. We get 40. So we are getting 40 I1. 40 I1 minus 10 I2 plus 120 equals 0. So we can reduce this by dividing throughout by 10. So if we divide throughout by 10, we get 4i1 minus i2 plus 12. This is equal to 0. So this is our equation 2. So we can move to mesh 3. So moving to mesh 3, what do we get? So if we move to mesh 3, there, so mesh 3. So from mesh 3, we get, so in mesh 3, so which one exactly is the mesh 3? So the mesh 3 is E. So mesh 3 we have got 10, 30 and 120 voltage source there. So we can go ahead and say from mesh 3 we have got the 10 ohm resistor. There are two currents opposing each other. The two currents opposing each other, we have got this one and this one. So we have got I2 and I3 there opposing at the 10 ohm resistor, and there at the 30 ohm resistor we just have one current source going through it. We have got only I3 going through the 30 ohm resistor. So let's go back and write the equation. So we have I3 minus I2 plus, so plus we do have 30 I3. There we have got 1 minus 120 volts. So reducing this, we have got 10 I3 minus 10 I2 minus 10 I2 plus 30 I3 equals 120. So in this case we can collect the like terms to say we have got 40 I3 minus 10 I2. This must give you 120. So how can we reduce this? So the common multiple is 10. The lowest common factor is 10. So we can divide throughout by 10 we get 4 I3 minus I2. This is equal to 12. So this is our equation 3. So we need to solve these things simultaneously. But how can we solve simultaneously? So solving simultaneously, I'm sure from equation 1, let's go back to equation 1. So this is our equation 1. 5i2 minus I3 here minus I1 is equal to 0. So let us make I1 the subject to the formula. So making I1 the subject to the formula, we say I1 is equal to 5i2 minus I3. That is from equation 1. So what I want to do is in equation 2, I have got I1. So I want to replace this I1 so that everything is in terms of I2 and I3, so that I can marry the two equations and solve them simultaneously. So in this case, let's go and replace I1. So replacing I1 there, we say we have got 4. What I'm replacing in equation 2, so I have got 4. Here is 5i2 minus I3 minus I2 plus 12. This is equal to 0. So what we get is we have got 20 I2 minus 4 I3 minus I2 plus 12 equals 0. So in this case, correcting the right terms, we have got 20 I2 minus I1, so we get 19. So we get 19 I2 minus 4 I3. This must give us negative 12. So this is my equation what? My equation 4. I have a new equation there, which I have named equation 4. So having this equation, and mind you, my equation 3 is 4I3 minus I2 equals 12. That is my equation 3 that I gotten previously. So now I've got 4I3E and 4I3E. So I'm sure it's very important I can rearrange this and solve these two simultaneously. So I'll start with negative I2 plus 4I3. This is giving me positive 12. So by using elimination method, by applying elimination method, I have this. So here I need to add. So I've got 18, 19 I2 plus minus I2. So there I'm getting 18 I2 negative 4 plus 4 I3, I get 0. So this is equal to negative 12 plus 12. This is 0. So my I2 is equal to 0. So the value of the I2 there is 0. So having I2 as 0, I will get this equation so that I can evaluate even I3. So next stage there, I'll get this equation negative I2 plus 4I3 equals 12. So if I substitute here, I substitute a 0. What I'm getting is this. So I'm getting 4I3 equals 12. So this my I3 is going to be 4. 3. 3. 3. So is it 3 amps? Yeah, it is supposed to be 3 amps. So having that as my I3, I think to come up with I1, we need to recall that I1, we made I1 the subject to the formula. It was equal to 5I2 minus I3. So my I1 there is equal to 5. Here is 0 minus my I3. My I3, the one I've gotten previously, is 3. So I'm arriving at an answer. I1 is equal to negative 3 what?